Good afternoon. This is Kavipriya, Assistant Professor, AC Department. I am going to discuss about the topic PN junction diode. Under this presentation, I am going to discuss about basics of diode, symbol for diode, operation, biasing, forward bias condition, reverse bias condition, and what is the VI characteristics, and finally about the applications of a diode. First, what is this diode? Diode is a two-terminal device which allows a current in only one direction, that too forward direction, and it blocks the current flow in the reverse direction. So, it is used in a devices which involves a sensitive components where there is a need to protect the sensitive components from the reverse current. It is used in the power adapters, radio receivers, LED lights. And next is a symbol for diode. It allows a current flow in forward direction. So it takes a symbol like a forward arrow. It has a positive and negative terminal. Positive is an anode and negative is a cathode. To identify the cathode, there will be a white line. And next is a construction of a diode. It consists of a p-type and n-type semiconducting material which are connected together. The majority charge carriers in case of p-type is a hole, and in case of n-type it is an electron. The junction between the P and N-type is a PN junction. And next is the operation of a diode. When a supply is given, electrons from the N-type will move towards the P-type and holes from the P-type will move towards the N-type. And results in a combination of electrons and holes, and which results in a flow of current. And next, what is the biasing in the diode? First, generally, what is this biasing? Biasing is nothing but providing a supply voltage for the device for its proper operation. In case of diode, we have forward bias and reverse bias. Under forward bias, we will be connecting the positive of the battery to the anode and negative of the battery to the cathode. Positive to positive, negative to negative connection. Here, the force of repulsion will take place. Positive of the battery will be repelling the holes and negative of the battery will be repelling the electrons. So, the depletion region, which is nothing but the junction between a p-type and the n-type material, will become very narrow. So, the electrons from the n-type will move towards the p-type and holes from the p-type will move towards the n-type. So, the combination of electron and hole will take place and results in a flow of current. This happens in case of the forward bias. And the depletion region will be very narrow in case of the forward bias. And this depletion region will itself disappears when the supply voltage is greater than the barrier potential. So normally, the semiconducting material that is used in case of a diodes can be a silicon or germanium. So the barrier potential for silicon is 0.7 and for germanium it is 0.3. If a supply voltage is greater than the barrier potential, the layer between the depletion layer between the P and N type will be completely vanishes. So more electron hole combination will take place and it results in a rapid flow of current. This is indicated by this graph. So up to this barrier potential, there will be a gradual increase in the current, and once a barrier potential is reached, there will be a rapid increase in current because of the more combination of electrons and holes. And next is a reverse bias condition. In case of reverse bias, negative of a battery will be connected to the anode and positive will be connected to the cathode. So negative to positive, positive to negative connection. So here the force of attraction will take place. Positive of the battery will be attracting the electrons and negative of the battery will be attracting the holes. So the depletion region between the P and N type layer will become more widened. Since the layer is being widened, the combination of electrons and holes will not take place and results in a no flow of current. This happens in case of the reverse bias. But practically, there will be some flow of current, when small flow of current in case of reverse bias condition. We call it as a reverse saturation current. The reverse saturation current is due to the minority charge carriers. This is the VI characteristics for forward and reverse bias. In case of forward bias, up to the barrier voltage, there will be a gradual increase in the current. Once a barrier voltage is being reached, there will be a rapid increase in current. In case of reverse bias, once a breakdown voltage is reached, there will be a small flow of current or nil flow of current. So once a breakdown voltage is being reached, there will be a rapid flow of current. And next we are going to discuss about the applications of the diode. It is used in the rectifier circuit to convert the AC to DC. It is used in the power supplies, and it is used in the places where voltage regulation is required. It is used for protecting the circuit. It is used in the LED lights, light emitting diodes. Whenever a light falls, whenever there is a light falls on a particular diodes, it allows a flow of current in forward direction. And next is the photodiodes. Photodiodes, whenever light falls on a particular diode, it will be generating the electricity. So LEDs are used in the illumination, display and backlighting, and photodiodes are used in the solar cells, photographic light meters, optical communication, and it is used in the light sensors. And final one is the assessment. What is the condition for the forward bias? So the positive of the battery will be connected to the anode and negative of a battery will be connected to the cathode. And next, in case of reverse bias, no current will be initially flows on. That is in case of the ideal. Whereas in case of practical cases, small amount of current will be flows in there, which is due to the minority charge carriers. We call that current as a reverse saturation current. And in case of photodiode, the depletion region between the P and N-type material will be completely vanishes when supply voltage is greater than the barrier potential. V is greater than the V0. V is a supply voltage and V0 is a barrier potential. So that's all about the PN junction diode. We have discussed about the what is a PN junction, what is a diode initially, and we have discussed about the construction, working principle, and we have discussed what is this biasing, forward biasing, reverse biasing, operation of a diode under forward bias and reverse bias, finally about the applications of a diode. Thank you.